Okay, 7.3. 7.3 is row echelon forms and back substitution. This works with our systems of 3 equations and 3 variables. Row echelon form is what we get when we have a stair-step effect and a single leading coefficient of the 1. When we're doing our kind of old way of doing it, we eliminated one variable from 2 equations and then picked 2 different equations and eliminated that same variable. We got a solution and we went and put that solution back in to get this 2 letters, and then we put 2 in to get 3. So we're going to do both methods on example number 1. So on example number 1, the first thing we're going to do is we're going to pick the 2 equations that we want to use. I'm going to pick the first one and the second one. When I do this, my x's go away, and it leaves a y and a z. Now if I pick equations 2 and 3, I need to multiply the top one by 2, the second equation by 2, so that I can eliminate the x value like I eliminated it in the first set of equations. So when I do this, I get y plus 5z is now 9. Now that I've taken 3 equations and I've eliminated them down to 2 letters, I can put these 2 letters, or 2 equations, together and solve it like I have been doing in the past. So I'm going to switch the signs of 1. So 2z is 4, so z is 2. Now I'm going to do that back substitution. I took 3 equations, made them into 2-letter equations, take 2, and I solved for 1 letter. I'm going to take the 1 letter and I'm going to put it back into one of the 2's. It doesn't matter which one I pick. When I put it in, I get 6, and I get -1. Now I'm going to take the 2 letters, and I'm going to put it into one of the 3. It doesn't matter, again, which one that I pick. I'm just picking the first one. So that x plus 2 plus 6, that's 8. Subtract it, I get a +1. Now I put it in triple order format of x, y, and z. Now this is our kind of old elimination form. What we want to be able to do is progress forward and use this row echelon. Now the row echelon is going to take a little bit of getting used to. It is something that comes in handy as we move forward, so we're going to introduce it and have you start practicing with it, but know you have a backup for right now. Eventually that's going to be your only way of being able to solve. Alright, so what we do is, with row echelon form, we want to get a staircase effect by doing rules. Well, the rules that we can do are what we can do anytime we manipulate an equation. We can do negatives, we can add them together, we can do multiples, but what makes it unique is that whatever you start with, that equation is going to stay. So what do I mean by that? All right, so on these equations, what I want to do is I like the positive 1x. What I have to do is get rid of the negative x and get rid of the 2x. Because I like the single positive 1x, because that's the definition of row echelon, is we want single x, single y, single z. The way that I can do that is I can eliminate this second row x by just combining row 1 and row 2. So the rule I'm going to put together is that, and I would normally write it on the right side, but I don't want to use that paper here. because I always want you to write it on the right side. So what I'm going to do is we're going to leave row 1, but in order to get rid of that x, I have to take row 1 plus row 2. What that means is that row 1 is staying and row 2 is changing by adding row 1 to it. So row 1 is staying. Row 2 is going to change by adding those together. So that becomes 0. That becomes y, 3z, and 5. And we didn't do anything to the third one, so it stays. All right, so right now we're on a good pace. We've got our x is a positive 1, our y is a leading positive 1, but now I have a 2x that I need to get rid of, and I have a negative 5 I need to get rid of. Well, I can only do one at a time. So what I'm going to do now is I'm going to get rid of this x. The way I get rid of it is I'm going to take negative 2 times the first row, and I'm going to add it to the third row. So that's my rule that I'm going to do. Row 1 is first, so that's the one I'm not touching. I leave it alone. But I'm multiplying negative 2 to it so I can add it to row 3. So negative 2 to row 1 is negative 2x plus 4y minus 6z equals negative 18. Row 2 I didn't touch. Row 3, I'm adding this multiple of it. So what does it become? Well, the x's go away, and I get a y. I get a negative z. And, oh, I'm sorry, a negative y, because that's a negative 1, negative or z. And then I get a negative 1. Okay, so now I'm getting closer. I got rid of the x's everywhere. I want the y that's in the second one. I don't want the y that's in the third one. So the rule that's going to allow me to get rid of this y is that I'm going to take and add row 2 plus row 3. So row 2 stays. Row 1 stays because we didn't do anything with it. Now when I add row 2 and row 3 is the one changing, row 1 stays, 3 changes, I get 0, I get 2z, because 3 minus 1 is 2, and then 5 minus 1 is 4. I'm almost there. I got a 1x, I got a 1y, but I need a 1z, so I have to take row 3 and divide it by 2. So I get the first one stays, second one stays, and then the third one becomes z is 2. Now, this is where we're going to start with our back substitution. I know z is 2. I'm finished with that one. So now I get to plug it in there. Y plus 3 times 2 is 5, so y is negative 1. I then get to take that and plug it into the other one. X minus 2 times negative 1 plus 3 times 2 is 9. So we get 2 and 6 for 8, subtract it, x is 1. The solution, x, y, z. And that's exactly what we came up with when we did it the other way. When we did 3 equations to 2 equations to 1. Right? However, this row echelon version, where we're going to start making rules, and we just keep what we don't touch, we keep the first one, and then change the next one. This is something we're going to do continuously in the next few sections. So what I would like you to do on the next page is I would like you to work out the example that's there, you should come to the conclusion that's 1, 2, 4, but I want you to work it out both ways. I want you to work it out with the systems of equations of elimination, pick 2, eliminate, pick 2, eliminate, and go that way. And then I want you to try running rules to eliminate. So get rid of x's, make them a 1. Get rid of y's, make it a 1. Get rid of z's, make sure it's a 1. So I want you to try coming up with some rules. All right, on page 4, go into your book, and I want you to fill in those from your book. If something comes out to infinitely many, again, we can do this with our substitutions. We can also do it with our row echelon, where we're going to change from one to the other. What's important if I work this out by hand is that you're going to come out that you get a 0 equals a 0 with this substitution. And when that happens, that tells you that there is infinite. What we need to do is go through it when we're going to do our row echelon. So let's take a look at our steps here. So the first thing is we're going to take equation 1, row 1, and we're going to add it to equation 3. That means equation 1 stays, and equation 3 is the one that's going to change. The next rule is that I want to multiply equation 2 by the scalar of 3. When I do that, first and third stays. I now am able to see how I can eliminate my y's by subtracting the 2 and the 3. When I do that, I get my equation, my third equation, to completely disappear. That is how I get kind of clued in that it's going to be special or unique. It might be no solution, infinite solution, whatever, but I need to go through the process. So when this happens, I now can look at just my second equation, and when I set that to 0 and solve this, I get that y equals z. And if y equals z, that means it is going to be some kind of infinity. They have a shared value. If it has a shared value, I need to find them in general terms. So in general, we're going to say a is any number that is y. Well, since y is z, that means z is also a. I can take that a and substitute it back into my other equation to find my x. Substitute a into y, substitute a into z, and I'm going to find my x value. When I find my x value, it is in terms of a, because remember, this is an infinite. So I want to find all the possible solutions, not just know that there are infinite solutions, all the possibilities of them. So I need to write them in this special format, which is 2a minus 1, y is a, and z is a. On page 5, it's pretty similar. It specifically talks about a square equation, same number of variables, same number of equations. So in this example, it's not square because there's 3 letters but only 2 equations. We would still approach it the same way, and we would combine, eliminate what we can. The z's eliminate automatically. I can then simplify this by dividing by 3, and I find that x minus y is 1. Because of this, I can solve for x and call it y is 1. The best I can do at this point is find it in general terms. So if I want to make y a to stand for any possible number, I now know that x is a plus 1. Well, if I know what x is and I know what y is, I can now substitute it back into one of my equations, it doesn't matter which one, and solve for z. In this case, z comes out to be a plus 1, and I get my ordered triple. We're going to skip page 6. I don't want to do it, so that will be all for 7.3.